Good morning, class 9. So we have already started coordinate geometry and we are solving questions from exercise 23C. Okay. So till question number 6 we have already solved, and 7 and 8, okay, you have to do yourself. So today we'll start from question number 9. Okay. So here the question is, the coordinates of the center of a circle are a plus 2 comma a minus 1. This is the center of a circle, and find a if the circle passes through 2 comma minus 2 and 8 comma minus 2. So this is circle, no, and this is called the diameter of a circle. Okay, the longest chord which passes through the center of a circle, this is called the diameter. Okay, and center is in the middle, no, middle. So the coordinate of this center is given a plus 2 comma a minus 1, and this circle passes through these 2 points. Okay, one point is a 2 comma minus 2 and another point is b 8 comma minus 2. So this circle passes through these 2 points and the center of the circle is this one. You have to find the value of a here. Okay, so see, O is the distance between AO and OB are equal. Okay, this is called the radius, also radius of a circle. So this AO and OB are equal. That concept you have to use. The distance between AO and OB are equal. So distance of AO is equal to distance of OB. So for the line AO, this is x1 y1, this is x2 y2. So the formula is same, square root of x2 minus x1 whole square plus y2 minus y1 whole square for both. Okay, both sides. But you have to understand, okay, for AO which one is x1 y1, which one is x2 y2. So x1 y1, x2 y2. Put the value x2 minus x1, x2 minus x1, y2 minus y1 whole square. Okay, square root cancel out. For the line OB, okay, this is x1 y1, this is x2 y2. So x2 minus x1 whole square plus y2 minus y1 whole square, y2 minus y1 whole square. Now the next one is, your 2 and 2 will cancel out, a square plus a minus 1 minus into minus plus 2 whole square. 8 minus a minus into plus minus 2 minus 2 minus a minus into minus plus 1 square. Next is a minus 1 plus 2. It is plus 1. Okay, plus 1 square, a plus 1 whole square. And here 8 minus 2 is 6. 6 minus a whole square plus minus 2 plus 1 minus a whole square. So here we have to use formula of a plus b whole square, which is a square plus 2ab plus b square. Similarly, here also we have to use formula a square, a minus b whole square, a square minus 2ab plus b square. So here, okay, what we will do is, we will take minus common. Okay, after taking minus common, here it will be 1 plus a whole square. Minus square is plus, so you have to use your formula of a plus b whole square. Okay, so a square plus 2ab plus b square. Then we have to simplify. Okay, 6 square is 36, 2 6 are 12, 12a, a square, this is 2 1s are 2, 2a, 1 square is 1, and a square and a square is already added here. Okay, here also a square, 2a square, this is 2a plus 1. Now next is 36 plus 1, 37 minus 12a plus 2a. Like terms but opposite sign, they will be subtracted. So minus 10a plus 2a square. Now we will keep everything on the left hand side. Okay, write all the terms of right hand side on the left hand side. You just have to change the sign. Then 2a square and 2a square will cancel out since they have opposite sign. 2a and plus 10. This plus 10a will be here. It will be 12a, and 1 minus 37. It will be minus 36. So 12a minus 36 is 0. So 12a is 36. So a is 3. The value of a is 3. Now number 10 is, if a point P a comma b is equidistant from a and b, means P is a point which is at equal distance from a and from the point b. That means these two are equal. Okay, that means P is in the middle. So here also distance of AP is equal to distance of PB. Same process, okay, and you have to prove here A is equal to B. Now same process, okay, AP is equals to PB. You have to use formula distance formula, square root of x2 minus x1 whole square plus y2 minus y1 whole square, both sides. Now for AP, this is x1 y1, this is x2 y2. So x2 minus x1 whole square plus y2 minus y1 whole square. For the line PB, this is x1 y1, this is x2 y2. So x2 minus x1 whole square plus y2 minus y1 whole square. Next is minus into minus plus, a plus 4 whole square plus b minus 3 whole square. 3 minus a square plus, take minus common from here, okay, so that it will be 4 plus b whole square. Now use your formula of a plus b whole square and here a minus b whole square. So formula is a square plus 2ab plus b square plus a minus b whole square formula. A square minus 2ab plus b square. Here again a minus b whole square, a square minus 2ab plus b square. Now I have already told you minus square is plus. So here you have to use formula of a plus b whole square. A square plus 2ab plus b square. Next we will simplify. 2 4s are 8, 8a, 4 square is 16. B square minus 2 3s are 6, 6b plus 3 square is 9. 3 square is 9, 2 3s are 6, 6a plus a square plus 4 square is 16 plus 2 4s are 8, 8b plus b square. Next is a square, then 8a you have to write 16 plus 9, it is 25, b square minus 6b, 9 plus 16, 25, 25 minus 6a plus a square plus 8b plus b square. Now keep everything on the left hand side, okay, write all the terms of right hand side on the left hand side, just change the sign. Next is a square and minus a square cancel. 8a plus 6a, it will be 14a, 25 minus 25 cancel. B square cancel. Now we'll have 8 plus 6, 14a minus 6b minus 8b minus 14b. Now 14a minus 14b is equal to 0. Take 14 common so that a minus b is equal to 0. So a minus b is equal to 0 divided by 14 is 0. Now minus b will become plus b on the right hand side. A is equal to b, proved. Number 11. This is homework, okay, but I will tell you how to solve the question. If the points 2, 1 and 1, minus 2 are equidistant from the point AB, that means the distance between this 2 points and these 2 points are equal, okay. This is the point which is in the middle of these 2 points. So let's give this point A and here it will be represented by suppose B, okay, and let's give the name of this point P. So according to the question, these 2 points are equidistant from P, means the distance between AP and PB are equal. Same process like question number 10, okay, you have to solve this question yourself. Next is question number 12, okay. Prove that the points 2, 3, 8, 11 and minus 1, minus 1 are collinear. First you have to understand what do you mean by the collinear points. These 3 points are called collinear if they lie on the same straight line, okay. If the points lie on the same straight line, then those points are called collinear points. So you have to prove that these 3 points lie on the same straight line. For that, okay, we'll write this point first A minus 1, 1 and this point as B and this one as C. Now we have to prove this 3 point lies on this straight line. For this, what we will do is first we will find the distance of AB, we'll find the distance of BC, then we'll find the distance of AC, okay. So we'll find first distance AB, okay. What is the distance between AB? So AB, for the line AB, this is x1, y1, x2, y2. Okay, use formula here, x2 minus x1 whole square plus y2 minus y1 whole square. x2 is 2 minus x1 is minus 1. y2 is 3 minus 1. Then minus into minus plus 2 plus 1 whole square plus 3 minus into minus plus 1 whole square. Now next is 2 plus 1 3, 3 square plus 4 square. 9 plus 16 25. Square root of 25 is 5 units. That means the distance between AB is 5 units. Now let's find the distance of BC. For the line BC, this is x1, y1, this is x2, y2. Again use your formula. Here you will get the distance 10 unit. That means this is 10 unit. Okay. So let's find the distance AC. Okay, the distance of AC. So for the line AC, this is x1, y1, this is x2, y2. So the distance of AC is 15 unit. We got this is 15 unit. See, total this is 15 unit. This is 5, this is 10. So 5 plus 10 is 15. And when you find AC directly, it is again 15. That means it shows that these 3 points lie on the same straight line. So calculation part is your distance of AB plus BC. If you add, it will come 15, which is the distance of AC. So it proves that these 3 points lie on the same straight line. So they are collinear. So here is the definition of collinear points. When the points lie on same straight line, they are said to be collinear points. Next is question number 17. Let A, B and C are vertices of a triangle ABC. This is a triangle. These points are called the vertices. Okay. So the vertices of a triangle are A 2, 2, B minus 2, 4 and C 2, 6. You have to prove that this is an isosceles triangle. That means these 3 points form an isosceles triangle. So you know what is an isosceles triangle? A triangle whose 2 sides are equal. So to prove it is an isosceles triangle, what we have to do, first we will find the distance AB, BC and AC. Then if any 2 sides comes equal, okay, if any 2 sides become equal, then yes, the 3 points form an isosceles triangle. So simply you have to find the distance AB, distance BC and distance AC. So find the distance of AB. For the line AB, this is x1, y1, this is x2, y2, okay. And formula is here, you have to put the values, okay. Then it comes root 20 unit. This is root 20 unit. Now we will find the distance BC. So distance of BC after solving, you will get again root 20 unit. This is also root 20 unit. Now let's find AC, okay. So for the line AC, this is x1, y1, this is x2, y2. So after using formula and putting the value, you'll get the distance AC is 4 unit. So here we got this is root 20, this is root 20 and this is 4. That means it is a triangle whose 2 sides are equal. So it is an isosceles triangle. If this also comes equal, no, then this triangle would have become equilateral triangle, but we got only 2 sides equal, so it is an isosceles triangle. Here we got AB is equal to BC, so triangle ABC is an isosceles triangle. Number 18, number 1 is so that these 3 points are the vertices of a right angled triangle. So these 3 points form a right angled triangle. So here also we will find the distance of AB, BC and AC. So how to prove that whether the triangle is right angled or not? For that you have to apply Pythagoras theorem. If Pythagoras theorem is applicable here, then yes, the triangle is a right angled triangle. So first you have to find the distance AB, distance BC and distance AC. So distance of AB, this is x1, y1, this is x2, y2. So here you will get root 8 unit. Okay, this is root 8. Now we will find BC. So BC you will get root 10 unit. Now AC is root 2 unit. So here this is root 8, this is root 2 and this is root 10. So right angle triangle is like this, okay. This is called hypotenuse, this is called perpendicular, this is called base. And I have told you in trigonometry that hypotenuse is the longest side. So this is root 10. We will consider this is root 10 and this is root 8 and this is root 2, okay. So let's apply here Pythagoras theorem. If it is applicable, then it is a right angled triangle. So for this, what we will do is, this is the longest side. So AB and AC are perpendicular and base. BC is hypotenuse. So you know Pythagoras theorem is hypotenuse square plus base square is perpendicular square plus base square is equal to hypotenuse square. So AB square is root 8 square, which is 8. AC is root 2 square is 2, 10 units. So perpendicular square plus base square is 10 units. So let's find hypotenuse square. BC square root 10 square is equal to 10. So we got here that hypotenuse square is equal to perpendicular square plus base square. So BC is hypotenuse. Hypotenuse square is equal to perpendicular square plus base square. So the given points are the vertices of a right angled triangle, because here Pythagoras theorem is applicable. Pythagoras theorem. So Pythagoras theorem is applicable only in case of right angled triangle. Now question number 2 is 18.2 is prove that A, B and C are the vertices of an isosceles right angled triangle ABC. So here you have to prove ABC forms an isosceles triangle, and that isosceles triangle is right angle also. Okay, you have to prove that. So here ABC you make like this, it is already given, it forms a right angle triangle. Okay, we have to prove it. Okay, and isosceles also. Now we will find the distance of AB, distance of BC and distance of AC. So any two length must be equal to prove it is an isosceles triangle. Okay, so distance of AB here it is root 52, distance of BC it is again root 52, and distance of AC it is root 104. So this is root 52 and this is root 104. No, so these two sides we got equal, so this is an isosceles triangle. Now one more step is there. Okay, we have to prove it is a right angle triangle also. So I have told you that we have to prove Pythagoras theorem here. Pythagoras theorem is applicable here. So hypotenuse square is equal to perpendicular square plus base square. So first we will find AB square plus BC square here. AB square plus BC square is 104. Now hypotenuse square AC square is again 104. That means hypotenuse square is equal to perpendicular square plus base square. So Pythagoras theorem is applicable, and here we got AB is equals to BC also. So it is an isosceles right angled triangle. And second part of the question is find the coordinate of D such that ABCD is a square. You know how square looks like, right? A quadrilateral whose all sides are equal and whose each angle is 90 degrees. That is called a square. Okay, so D is a point. Okay, so that ABCD forms a square. This is right angle triangle, so D will be here. Okay, so you have to find the coordinate of D. What is the coordinate of D? So let's take the coordinate of D be A comma B. Okay, so here in square this AB, BC, CD and AD are equal. Okay, so if you use distance formula it will be too lengthy. Okay, too lengthy, and you'll get this one simultaneous linear equation. Again you have to solve it because here we have two variables. So okay, I'll show you the shortcut method. I'll give you one extra formula which is of class 10. Okay, that formula is not in class 9, but that class 10 formula will make this question very easy. Okay, you will get in few lines only. So that formula is, see, this is the midpoint. No, you know these lines are called the diagonals. You have learned in class 8 or in class 7. See, the line which join the opposite vertices of a quadrilaterals are called diagonals. So these are diagonals. So in square the two diagonals will intersect at this point. This is the midpoint. This is the midpoint of BD and midpoint of AC. So here we will use midpoint formula. Okay, this is the midpoint of BD and AC. So midpoint of BD is equal to midpoint of AC. So midpoint formula is, if you have to find the midpoint, okay, the point which is in the middle of 2 points, the formula is x1 plus x2 by 2 comma y1 plus y2 by 2. So here we will use this formula. Midpoint of line AC is equal to midpoint of line BD. So for AC, x1 y1 x2 y2. So midpoint is x1 plus x2 divided by 2, y1 plus y2 divided by 2. And for the line BD, this is x1 y1, this is x2 y2. Now we will put here the values. After putting the values here, you will get minus 5 plus 5 0, 0 by 2, 2 plus 4 is 6. 6 by 2. They can't be added because one is constant and another is variable. So this one also remains same. 0 by 2 is 0. 6 by 2 is 3. So to find the value of a and b, we have to compare both sides. Okay. In place of 0, here we have minus 1 plus a by 2. And in place of 3, we have minus 2 plus b by 2. Then 2 into 0, 0 minus 1 plus a is equal to 0. So a is equal to minus 1 will become plus 1. So a is 1. Here 2 3s are 6. So b is equal to 6 plus 2, 8. So here the coordinate of d is 1, 8. Now question number 19 is, so that the points minus 1, 3, 3, 6, 6, 2 and 2, minus 1 are the vertices of a square. So you draw one square, okay, and whenever you write the points, you have to write in sequence, okay, A, B, C, D, or you can write A, B, C, D, okay. So you know in square all the sides are equal. That means here you have to show that all the sides are equal, okay, A, B, B, C, CD and AD or DA are equal. So you have to find the length AB, that means distance of AB, distance of BC, distance of CD and distance of DA. Okay. So when you find the distance, you will get in each, okay, you will get 5 unit. Here also it is 5 unit. So CD is also 5, DA is also 5. That means all the sides are equal. It is a square. Now next is you have to find its perimeter, okay, perimeter of this square. Perimeter means length of this boundary, okay. This is 5, 5, 5, 5. So it is 20, no, total length of the boundary is 20. But we have formula to find the perimeter of a square, 4 into side, okay. There are 4 sides and its sides are equal. So the perimeter of a square is 4 into side. So 4 into side, 4 into 5, 20 units. Now 21 is, so that a quadrilateral ABCD with vertices A, B, C and D is a rhombus. Okay. So rhombus is also a quadrilateral whose all sides are equal. Okay. But what is the difference between square and rhombus? See, in square each angle is 90 degree. That means each angle here it will be 90, 90, 90. But in rhombus, okay, we draw rhombus like this, okay. So the diagonals of a rhombus are perpendicular to each other. That is the difference between square and rhombus. In rhombus, the two diagonals intersect at 90 degree. That means in rhombus, okay, the two diagonals will make 4 right angled triangle. And I have told you that the each side of a rhombus are equal, okay. In square and rhombus, all the sides are equal. So here what we have to prove is, we have to prove any one of the triangle is right angle triangle, okay. So we will start here. Here I have already written, to prove ABCD is a rhombus, we have to prove any one of the triangle is a right angle triangle, because all the 4 triangles are similar. So you have to take any one triangle and you have to prove it is a right angled triangle, okay. For that we need this one. Right angle triangle means you have to prove Pythagoras theorem. So you have to find this hypotenuse, you have to find perpendicular, you have to find base. Hypotenuse is AD, no, so you can find the distance of AD. To find this AO, we will find the distance of AC, okay. The distance of AC will give you AO, because AO is half of AC, and to find this OD we will find BD, so half is OD. Now distance of AC is, this is x1 y1 x2 y2 formula, x2 minus x1 whole square plus y2 minus y1 whole square. Put the values, okay. Minus square is plus 25 plus 25 is root 50, and root 50 means 5 into 5 into 2. So this 5 have paired, so it will come out of root 5 root 2 unit. So AC is 5 root 2, this one, okay. AC is 5 root 2 unit. This is x1 y1, this is x2 y2, okay. Now we will find BD also. So BD is, this is x1 y1, this is x2 y2. Then we will find AD. So BD you will get 9 root 2 unit. So here AD is root 53 unit, okay. So AO is half of AC and OD is half of BD. So AO you will get 5 root 2 by 2 and OD you will get 9 root 2 by 2 units, okay. And now we have to prove Pythagoras theorem. Hypotenuse is AD square is root 53 square, which is 53. Perpendicular is AO and base is OD. So perpendicular square plus base square. 5 square is 25, root 2 square is 2, 2 square is 4. 9 square is 81, root 2 square is 2, 2 square is 4. You can cancel this 2 and 4, 2 and 4. So 25 by 2 plus 81 by 2, 25 plus 81, 106 by 2, which is 53 unit. Here also 53 unit, that means hypotenuse square is equal to perpendicular square plus base square. So we have proved that the triangle, this triangle is a right angle triangle. That means all the triangles are right angle triangle. This is a rhombus. Now 23 is find the length of the diagonals of a parallelogram with vertices as a 6, 8, b minus 14, 8, c 8, minus 2 and d minus 12, 2. So this is a parallelogram. You know when a quadrilateral is said to be a parallelogram, when the two opposite sides are equal, means AD is equal to BC and AB is equal to CD. Okay, so it is called a parallelogram. Two opposite sides are equal. In question number 22, you have to prove it is a parallelogram. Okay, so how to solve? You have to prove AD is equal to BC and AB is equal to CD. So 22 is homework. Here 23 is you have to find the length of the diagonal. These are called the diagonal. So you have to find the length of AC and length of BD. Okay. So AC and BD are diagonals of a parallelogram. First you have to find AC. For this line AC, this is x1, y1, this is x2, y2. Now for the line BD, this is x1, y1, this is x2, y2. So AC you will get root 104 units and BD also 104 units. So this is a parallelogram whose two diagonals are equal. That means this parallelogram is a rectangle also. Okay. So this is the last question. Now 23 you have to solve yourself. So this much for today. In next class we will start graph.